So good morning, everybody. This is an exciting day for iMasons, and I'm sure for the scholars at Hampton University. You know, this past year, we've been expanding iMason's strategy, and you'll hear more about that in the APAC Regional Summit tomorrow. But one of the constants since the beginning of iMasons has been our focus on increasing the flow of talent into our industry. So one of the key challenges has been helping new college graduates bridge the gap to their first job in the digital infrastructure industry. You know, employers often want to hire people with experience, but how do you get that experience? It's a chicken and egg kind of thing. So guided by our education committee, which is chaired by Dennis Cronin, by the way, and a big shout out to Dennis. Thank you very much for your leadership. We've come up with a few ideas on how to help bridge this college to industry gap. And today we're seeing the results. So I'm going to tell you a little bit more about this program now. So, you know, many bachelor's degree require a senior design capstone project. This is intended to help the students integrate the learnings from their 4 years and apply it to a real world problem. The idea was to create a capstone project that introduced the students to the breadth of our industry, from designing the infra to support booming demand, through site selection to financing and designing a data center. Well, we'd been chewing on this idea for a while when we were introduced to Hampton University, a small historically Black university in Southern Virginia with a small technology and engineering program that includes electrical and computer engineering and architecture. Here with us today is Dr. Dimitris Geddes, Assistant Dean of Hampton School of Engineering and Technology, and Dr. Chang Lee, Professor of Electrical and Computer Engineering at Hampton, and the faculty advisor for the Electrical and Computer Engineering capstone projects.
Again, I would like to thank you all for attending our capstone design presentation. Again, I'm Dimitris Geddes. I am the Assistant Dean for the School of Engineering and Technology. And just to give you a little bit of information about Hampton University. So we are a private HBCU that was founded a little over 150 years ago by a colored troop general from the Civil War, General Samuel Chapman Armstrong. And one of the things that he wanted to do was to train newly freed slaves in terms of their hand, their head, and their heart. That's actually the center of engineering. And so engineering has really been sort of a part of our university for quite some time. Matter of fact, we're celebrating 25 years as the School of Engineering and Technology in a couple of days. So one of the goals, again, is to produce leaders. And so founding, we were, most of the graduates were teachers. Now we have the opportunity to partner with you guys, and you guys are actually training leaders for the digital infrastructure with us. So just some numbers about the university. Currently, our enrollment is about 3,500 students, 3,000 of those being undergraduate and another 500 or so being graduate students. The School of Engineering and Technology, which is led by Dr. Joy Shirazi, has about 230 students. And so we actually have chemical engineering, electrical engineering, computer engineering, but we also have aviation and architecture. And so this project allows us to actually have this multidisciplinary culminating project for our students. And so again, for all engineering programs, our students have to demonstrate that they're able to take their coursework that they've learned while they were at Hampton and apply it to designing a real world problem. And so it's been great. This has been a great partnership. So you guys presented a real world problem for us and for our students. And really our students have the opportunity to select any project that they want to work with. And so Jeff and team actually did a pitch to our students, and they were inspired to take up this challenge to design a data center. So again, I thank you guys for that. And as I told the first group, this is, so as a freshman, they came in and they were supposed to uphold a phrase that we have here, good, better, best, never let it rest until your good is better and your better is best. And I look forward to seeing them do their best today. So I pass the mic to Dr. Lee.
Thank you, Dr. Gates. I want to echo what Dr. Gates just said. This semester has been very interesting. Capstone design is a year-long 2-semester required course for all electrical and computer engineering students to graduate. Typically, our students design a product using the knowledge in circuits, electronics, and the microcontroller, etc. This capstone design with partnership with iMasons is rather unique. I have learned a lot. I bet our students have too. I'm looking forward to the second presentation. Thank you so much.
We actually have a few faculty members that are on as well too. And so we actually have Dr. Nare and Dr. Sun that are actually, we're grading our students as you guys are grading them or giving them feedback as well too. So Dr. Nare, Dr. Sun, do you guys have any comments you'd like to make?
The only comment I would like to make is that we are looking forward to the second presentation. I think the first one was fantastic, and we're also looking forward to future collaboration.
Dr. Geddes, I think it was Philip Marangella who originally introduced us to each other and iMasons to Hampton. And your initial interest was creating a data center lab at Hampton that we were, beginning to talk about. We've been pretty busy this quarter, this last year, academic year, with the Capstone project, but we haven't dropped the idea on the lab. And I want to come back to that. And we'll hear more about that later. So thank you, Drs. Geddes and Lee, for making your students available to us and giving us this opportunity to work with these bright young scholars. So I want to shift gears and shift it over to introduce the mentors, Philip Marangella, Cheng Lim, and Bill Clayman, who met with the students every week. So Philip, in addition to making kind of the initial introductions that started this thing off, as I said, was also a key member of the mentor team that met with the students weekly. So Philip, you were one of the sparks who lit this fire, and you stoked it every week in these meetings. Why'd you jump in with both feet?
Thanks, Jeff. Thanks, Dr. Geddes, Dr. Lee, and the rest of the team. Look, this all, started to pull the string and got us to where we are today. It's just been a fantastic experience, right? For us in the data center business, right? These builders of the digital infrastructure. When we went to university, there wasn't a data center degree, right? So, and one of the key drivers for the Masons is centers around education. The other tenets are around diversity and inclusion, sustainability, and technology and innovation. And as we started this engagement with Dr. Geddes, it really got that light bulb came off of like, hey, could we collaborate and try to help train some students and form a way to help bring in the youth and to the data center industry. And so that resulted in the formation of this Capstone project. And it's just awesome to see the evolution from that initial idea and those just first conversations to where we are today, and see the growth and progression with these students that knew nothing about data centers, right? Brilliant engineers and so forth, but not realizing how much cool stuff and cool companies and all the great things that actually happen inside a data center. And so that's what's been really rewarding for myself, and I know for the other mentors. And I'm excited to see Hampton being that pilot program, right? And being this kind of first graduating class, if you will, for this, as we look to evolve into other universities and expand it into kind of master's programs, if you will, and really get that ball rolling. So I'm excited to hear today, to watch the culmination of the past year and as it sets the stage for the coming year. And again, I'm the chief marketing officer at EdgeConneX, right? A kind of global data center operator. But it's also been great with my fellow mentors that have complementary kind of skill sets and experience, and how we also played off each other to help these students, right? And at the end of the day, it's all about the students. I know last session, Bill had my fellow mentor, Bill Clayman of Switch, had the chance to kind of talk about his experience and background. This time, Chang, I want to pass off to you and give you yourself a chance to talk about your background and your experience involved in this initial project.
Thank you for that, Philip. I really appreciate it. It's been such a great experience to work with this group of students. They've all worked incredibly hard. I still remember when Jeff, it was you that approached me. I think it was in September or October of last year, to mention that we were fortunate to have a group of architecture students joining the project. They were starting in the project a couple months behind the engineering students, and we had to very quickly get them up to speed with all of the requirements and criterias for designing a data center. And I remember the first time that I gave them my an architecture design presentation to explain how data centers are constructed and just overall how the data center industry works. And I remember that their jaws just dropped at the implications of all of this. Like, we talk all the time about the cloud, and it was very quickly dawned on everyone that the cloud isn't truly in the cloud. The cloud is a very physical thing that needs to be built and constructed and financed and operated. And to see the global consequence of that was, I could tell that from the students' reactions that it was just mind-blowing to them. And yeah, like everyone has echoed, a program like this has never been done before. And so I definitely credit the iMasons team for leading this effort. Our industry very much supports the internet and the cloud infrastructure, but very few people know about it. And certainly in my field, in architecture, most architects aren't familiar with the specific technical and programmatic expertise to design a data center. I'm an associate at Sheehan Hartrey. Our office does hyperscale and co-location design for a number of clients, and we oversee design and construction on their behalf. I have personally enjoyed this opportunity to teach, and I love to promote and advocate for the mission critical industry. Our office has also been very incredibly supportive. I had a team from the office who regularly joined our efforts, and we held regular architecture design review sessions with the students. So definitely a shout out to the rest of the Sheehan Hartrey team for their support. I think the students have come a very long way since the very beginning, and I'm just absolutely so proud of everything that they have accomplished, and I can't wait to see Team 2's presentation.
Fantastic. Well, Philip, Bill, and Chang, thanks so much for your work throughout the team. It's been great to work with you, and I think you'll be able to join again at the end. So let's move on in the presentation right now to introduce the executive evaluation panel that have joined us just for this. So let's go around the virtual table. Let's start with Randy, and then Ian, and then Charisse. Randy, are you on and able to introduce yourself?
Hello and welcome everybody. I've been looking forward to this day since it's been on my calendar now 6 weeks ago. So thank goodness we've arrived at this day. By way of introduction, I am Randy Brockman. I'm actually the co-founder and CEO of EdgeConneX. So I work for Philip. That's kind of how it works. But we've been together almost a decade now, working here. Really looking forward to it, folks. Thanks for digging in, doing the heavy lifting, and the effort you put into this project. I've been hearing about it kind of each step of the way. And Jeff, a special call out to iMasons. This is the right thing for the right reasons, with the right results. Right. This is what iMasons was. We could have hoped it to be. Right. Making infrastructure a core curriculum, in improving, the opportunities for these young scholars, and doing our part for diversity, equity, and inclusion for sure. I couldn't be happier, and I'm really excited about it. Thank you.
Well, thanks, Randy. That's really kind. I appreciate your support. So Ian, and then Sharice and Zal.
Hi, everyone. So my name's Ian Whitfield. I'm Chief Technology Officer for Pure Data Centers. Similar to Randy, we're an international data center operator. Our footprint is mainly in UK, Middle East, and Asia. So excited to be joining up with you folks in Hampton and understanding a little bit about US style data center design. Yeah, looking forward to the presentations coming. My bias is engineering and sustainability as opposed to computing. So yeah, really interested to see what's coming up. Thanks.
Hi everyone, I'm Zal Mbawala in London. As you can probably tell by my accent. Electrical engineer by education, but I defected to the world of computer science and computers many years ago. So have sort of one foot in both camps. I work at the moment for CBRE, pretty much, I think, the world's largest real estate business, and certainly the largest outsource operator of data centers globally, about 900 data centers. And I look after strategy for them. Super excited to be here today. I remember about 15 years ago, I did a presentation on what a data center is to a group of electrical engineering students at Bath University here in the UK. The questions I got were amazing in the sense that they really broke the mold of we've been doing things the same way over and over again. So having fresh blood and new thinking and unconstrained, I'm really excited about what we're going to hear today. So thanks for letting me be part.
Hey, my name is Eddie Shooter. I'm the CTO at Switch. I've been in the industry for about 30 years. And I'm also a board member with iMasons, and I'm looking forward to hearing the presentation today. I'm honored to be a guest. Thank you.
And Maricel?
Yes, thank you. My name is Maricel Cerruti. I'm also a founding board member of Infrastructure Masons and a principal at Teledata. I'm responsible for marketing business development for that firm. Teledata is a low voltage technology consulting firm, and we specialize in data center and technology workplace. Really excited to hear the presentations and to be part of the panelists.
Thanks, Maricel. And let's wrap up with Peter.
Hey everyone, I've been throwing out a lot of chats out here on the sideline, just trying to leverage, trying to obviously see some of the LinkedIn posts that are going out there, but students, teachers, look, we have a lot of different LinkedIn links you can go out there. I just threw mine out there too. Let's leverage all your networks. Let's leverage a lot of panelists out here. Let's do what we can here, because the ultimate goal here is to find a job. So so let's go out there and do what you can, but let's make sure you guys are properly leveraging what we're doing over here, because ultimately you're here to get a job. So good luck. Looking forward to seeing the presentations. I'll be on the sidelines.
Quite an impressive group. So thank you all for joining. This is just great. So let's move on to the student presentations. So a couple guidelines as we get ready to hear the students. One, this has been a year-long 2-semester project executed for the first time ever in Hampton's, or really anybody's history, virtually due to COVID. So the students haven't actually probably seen each other this entire academic year. This was all done from their bedrooms, which is, all the more impressive. So for the first term, the students were given a fictitious mobile app with given latency and bandwidth requirements and a user growth curve in the US market. And their assignment was to figure out how many data centers of what size to put where to service that app's growth. And they had to consider all the typical things for site selection, which I won't go through. So they presented that at the end of the first term back in November. You'll hear a summary of that work, of what they did. But they've been evaluated on that already. That's passed. So for the second term, which just started in January here, the assignment was to pick one of the sites where they wanted to build a data center and design and build it, on paper anyway, So they had to select the IT equipment, figure out the power, the network connections, cooling strategy, lay out the building and site, and finally develop a CapEx and OpEx budget for their data centers. So now, without further ado, allow me to introduce Team 2 team leader, Ikena Nwagbara, to kick off his team. Ikena.
How you guys doing? Like you said, my name is Ikena, and I'll actually pass it to Jai, who is also the lead on this project as well, to start off this project for us.
Well, hello, everyone. We are presenting on behalf of Mozi and iMasons, and this is our senior capstone.
Good afternoon, everybody, and welcome. My name is Anna Burness-Kelly. I am a rising fourth-year architecture student seeking my master's degree in architecture, and I am from Norfolk, Virginia.
Good afternoon, everyone. I'm Christian Galindo Torres. I'm a fourth-year architecture major and class representative of fourth-year studio. I'm originally from San Diego, but my home base is in Norfolk right now.
Good afternoon. My name is Melanie Holguin. I am originally from Peru, living in Virginia Beach, and I am a four-year student in architecture, currently living in Virginia Beach, like I said before.
Hello, everyone. My name is Marquise Hall. I'm a senior electrical engineer major at Hampton University, and I'm from Long Island, New York.
Hello, everyone. My name is Jai Huntley. I'm an electrical engineering major, leadership studies minor from Kansas City, Missouri.
Hello, everyone. My name is Keatre Cately. I'm a senior electrical engineering major from Norfolk, Virginia.
And how are you guys doing, everybody? Again, my name is Ikena Nwagbara, and I am a senior computer engineering major from Atlanta, Georgia.
So our project was a year-long study and analysis on data center design. It was split into two phases, phase 1 and phase 2. So phase 1 took place during our fall semester, and we looked into the determining our application market, the growth of our application, as well as the latency for our users, the site and size for and of our data center. And then we transitioned into phase 2, which took place during our spring semester. And that utilized the information from phase 1 to help us design our data center from the inside out. So with that, our outline is as follows. We'll cover our application overview, the data center market analysis, data center design, CapEx and OpEx, some of the green initiatives we looked into, and then we will conclude. So Mozi supports a comment feature, video conferencing, and photo and file sharing. So with that, our minimal latency to maintain a good user experience is 50 milliseconds round trip. So at max, our app will consume 4 megabits per second of bandwidth, and that'll cover the worst case scenario of everyone using our application at once. To reduce CapEx costs, we will partner with CDN and edge providers to support remote markets. As previously mentioned, our latency is 50 milliseconds, which equates to 2,700 miles. 2,700 miles covers the entire United States. So with that, we were able to decide whether or not we wanted 2 small data centers or 1 large data center. If we went with 2 small data centers, each data center would be 16 megawatts. But if we went with 1 large data center, it would be 32 megawatts. So we went in the direction of the larger data center, and we now have 1 32 megawatt data center.
So as we were deciding on how large we wanted our data center to be, we had to select the tiering. The tiering consisted of 4 selections, 1 being the smallest, with 4 being the highest. So our thought process in that tier 1 was a bit too small. It was more so for local businesses. Tier 2 met more of our requirements that we wanted for our data center, but it lacked redundancy. And tier 4 happened to be a little too expensive. So we ended up going with tier 3 data center standards, which has uptime of 99.982%. The network streams are fully backed up. It could sustain natural disasters, and it was the most recommended tier for growing companies. So once we decided what tiering standards we would use for our data center, we had to look into location. And looking into location, we had to come up with a criteria for how we would pick our site. So the criteria consisted of power access, cost of real estate, lower risk from natural disasters, energy, fiber optics, taxes and incentives, and a common data center location. So here you can see this spreadsheet. This was a ranking system that we created to eliminate bias in our selection process with a priority ranking of 1 to 6. 1 being the most important priority and 6 being the least. And from the ranking system of 1 to 5, 1 being the most expensive, 5 being the cheapest for certain categories. So the higher the rating for each part was, the better choice for our location. So going into this project, we didn't know much about data centers and which specific states would be the best to choose from. So we originally had locations from all regions: Boise, Idaho, Dallas, Texas, Des Moines, Iowa, Kansas City, Missouri, Phoenix, Arizona, Reno, Nevada, Richmond, Virginia, Virginia Beach, Virginia, and San Antonio, Texas. So here's a specific example of our ranking system with Dallas, Texas, Phoenix, Arizona, and San Antonio, Texas. So as you can see, in regards to energy rate, Dallas had the highest energy rate, and natural disasters ranked well as also. So the total score tallied up. You see Dallas, Texas had the highest score, and San Antonio, Texas was the second highest, and Phoenix, Arizona was the least score. So all 3 of these sites ended up being eliminated, but that shows you how the ranking system worked. So out of these 3, Dallas, Texas would have been able to move on into our choice for our site selection. So our finalists, it ended up coming down between Kansas City, Missouri, and Reno, Nevada. So Kansas City, Missouri, it met the criteria fairly well, had high land availability, the low land costs, but as far as weather, natural disasters, it happened to be specifically tornadoes affected Kansas City more. So that was really what the deciding factor on why we didn't choose Kansas City. Here, this graphic, you can see the power optic lines going through Kansas City. So Kansas City, like I said, met our criteria fairly well. We ended up deciding to go with Reno, Nevada. Nevada met all of our criteria and had a slightly better ranking than Kansas City. It had the high land availability, low land costs, and safer weather. It's almost no natural disasters happening in Reno, Nevada. So that was another good thing that we account for in determining which site we were using. So here's a little graphic to show you that natural disasters rarely happen in Reno, Nevada. You can see tornado alleys, hurricanes, doesn't really happen that much.
Yeah, as Marquis said, the site is in Reno. The data center is located between the California border and a neighborhood. An existing train track will function as a barrier that will provide security and privacy to the data center from the nearest neighborhood located on the east.
The original intent with this plot of land was to make a large road that splits off here to circle around the building and then connect to its natural end, which was somewhere around here. This was to allow large trucks to make deliveries without having to make tight turns, but ultimately we went with a simpler design that didn't disturb too much of the site. The final iteration calls for the road to be split in 2, with one branch leading users over here to a small parking lot near the offices, and the other making use of the already existing road that runs parallel to the train tracks. That road also gives delivery drivers the opportunity to back into the loading dock with this segment of road. Because of the nature of the existing road, we felt it made the most sense to orient the building to fit the form of it, with the offices on the opposite side of the building from the sun to prevent overexposure of harmful UV rays. However, along the way, we found a product that could take advantage of UV radiation. Enter our use panels. They're made up of 80% plant waste matter, so they're biologically engineered to collect and harvest UV radiation, then convert that radiation into practical electricity. These panels work all day, even on cloudy days, giving them an efficiency of 50% versus traditional solar panels, which max out at 25%. Not only that, they're also very good at absorbing heat energy, so harmful glare and insulation against desert heat becomes obsolete. They come in different colors, as you can see, but we decided a simple orange would look best in an environment like Reno. We did research on the local fauna and found this female long-nosed leopard lizard's patterning matches the color of the RU's panels perfectly. So we mimicked its tan monochrome pattern and texture along with its color. We did think about making this building a multi-level data center to further add efficiency to the layout of the server rooms and have fewer hot aisles to manage. However, we ultimately decided to keep it at one level since that is actually more efficient than a multi-level data center. The culmination of all this process became the Mozi data center. As you can see, it's still highly decorated with RU's panels, including the parapet, although we were careful with how many of these should be transparent or at least visible from the outside. For example, the offices and waiting rooms down here are lined with transparent ones, but in moments like the parapet, they're just a facade element. They are still fully operational though. They still work very hard to convert UV into electricity. And we did leave some areas to be fully glassed, like the north side of the building, so as not to oversaturate the offices with its signature orange glow. And now I'll hand it off to Anna.
What you're looking at on this slide are the exterior elevations in full length of the entire building. So the top view is the north elevation, whereas the left-hand side is the loading dock area and the right-hand side is the, excuse me, front of house. And the bottom elevation shows the west elevation, which has the server room on the left-hand side, and the right-hand side is the loading dock area. This slide shows the floor plan that we created, but it is oriented horizontal. So the true orientation on site is about 30 degrees to match the orientation of the railroad tracks, like Christian mentioned.
In here, you can see the front of the house. The main entrance, which is on the west, will take you to the security area, then going through the waiting room, either revolving doors to the corridor. From there, on the right, it will take you to the server room, and on the left will take you to the area of the open office, private office, conference room, workstation, lounge, which will be equipped with a mini kitchen, and a game room are located. Also, there are partition walls in both sides where whiteboards, corkboards are incorporated where employees can use to facilitate collaboration. Employees in the workstation will have easy access to the server room because of the proximity. And also the security room will have an access from there in case of any emergency. That way, nobody needs to go through the waiting area to the main entrance to go to the security area.
As you walk down the corridor from the office area, first you will come to the fire sprinkler / pump room for the facility. And marked with number 10 are the bathrooms for men and women. And right next to that is the vestibule for the shredder room. And marked as number 12 is the shredder room. This is where all of the equipment, these are the big shredder rooms where they would take the CPUs to get chopped up, so nobody else, for security reasons. And as you exit the end of the corridor, marked as number 13 is the loading dock area. And marked as number 14 is the open platform for the trucks to back up to. It will be protected with an overhang. There are overhead coiling doors for easy access in and out to move, equipment to be loaded on or off the trucks. And to the right of that, the platform for the trucks is at ground level, at levels. But that will be explained later in the building sections. And now I pass it off to Christian to talk about the server room areas.
Thank you. The server room is easily the largest space of the data center with 3,514 racks taking the majority of its space. The hall is so big, in fact, that we thought it was necessary to add a few electric scooters near the entries, complete with their own charging stations. The electrical room is directly adjacent to the server room to the south of the building to provide further efficiency in powering the server hall. It houses all of the transformers, busways, switchgear, CPSs, distribution boards, electrical panels, and all those necessary equipment. The generator field on the opposite side of the electrical room, which makes a home for 14 generators. And a mechanical space is located on the east side of the building, a back of house element far from the offices so as to not disturb the employees.
Thank you, Christian. The building is designed to be a CMU, concrete masonry building, along with metal studs as needed, but to go green, wood studs can also be incorporated into the structure of the building. As you can see here, it is a building section partially cut through the server room, showing the hot aisle areas and the flow of the hot air into the plenum space, where the red arrows are on the left-hand side. And below that is about an 8-foot crawl space to allow for all of the piping, conduits, and wiring coming from mechanical room, electrical room, and the generator yard. And beyond that, on the right-hand side, you can see that the ramp for the trucks is sloped to accommodate for the loading platform. The bottom section is the section at the front of house, showing the windows, the different offices, the different wall heights for the walls to accommodate the whiteboards and the corkboards. This section shows the section cut through the server room along with the loading dock area. As you can see on the left-hand side is the crawl space / interstitial space underneath the server room area. And on the right-hand side, you can see the elevation change of the loading dock area.
So here's a graphic of fiber routes. Specifically, it's showing routes running through Reno, Nevada. And so since our data center in Reno, it's specifically near a train tracks, fiber routes are running through train tracks often. So that puts an emphasis and shows exactly routes running through Reno, Nevada, specifically our data center location. So we looked into fiber connectors. There were several options: SC connector, LC connector, FC connector, ST, and MPO. So each had its own specific, unique qualities, but ST was considered the most well-known, well-used connector out of all of them, but LC has recently became the modern version that's used most often. It has high densities, cost-effective, and good field fit. As you can see, that's a picture of it showing a push-pull connector. It's fast and easy to operate, and it's also at a very small size, so very easy to manage, and that's the connector we chose to use. So with our cabling, looking into fiber and also copper, we decided it would be best for our data center to use both. Fiber and copper both have its own specific qualities. Fiber is a bit more expensive than copper, but if you think about the durability of fiber and cabling, it's actually better than copper, so it might save you money in the long run. Both have different bandwidth availabilities, 60 terabytes for fiber and 10 gigabytes for copper. Shows different distances. So in regards to our network gears, we looked at different vendors, partners to use. Arista, Cisco, and Dell were a few options we looked into. Being that Dell was so common to us and we knew about Dell from before, we decided to partner with them for majority of the equipment needed. So within our fiber, we had to choose between using single mode fibers or multi-mode fiber. For our data centers, for our app, Mozi, it's very important to reach a wide range of states. So we're going to be using the single mode fiber as it works better for longer distances.
Okay, so initially, when we were looking for servers to house all of our data, we took into account two companies like Marquis said, Dell. And we also looked at HP. The Dell servers we were looking at were the PowerEdge model, R840 and R940 rack servers, as well as the HP ProLiant DL180 and DL160 Gen 10 servers. And here are their prices and their power consumption below that we also took into account. Next, we ended up selecting the Dell VxRail E-Series. because of its hyper-converged infrastructure. And here are all the specs that come with the E-Series, as well as the dimensions. And the price for the E-Series is about $65,000 to $85,000. And here's also a picture of it as well. So the reason we selected the VRAIL E-Series was because of the hyper-converged infrastructure, which saves us time because we're cutting down 2/3 of the components into one, saving on network space and being able to efficiently send traffic through the server. Also, for its scalability, we're able to basically take most of the server. We're able to just plug in servers and not have to take into account downtime or any of those other bottlenecks. And it's easier to scale out to bigger and more data consumption. We also looked at its high availability and reliability, as well as single-click provisioning, and we also were able to save on staff because we didn't need a bunch of siloed individuals taking care of each part of the stack. We were able to just use one expert in admin to run essentially the entire center. And we also looked at its improved intra-network security as well. And so for our firewall, we went with the Barracuda Cloud Gen Firewall F-Series. Basically, here are the different throughputs that it's able to take into account for. And the reason we chose this firewall is for its security and its SD-WAN capability. So basically, it provides comprehensive next generation firewall protection, firewalling, the IPS, the URL filtering, dual antivirus, and application control take place in the data path, and sandboxing and other resource-intensive tasks that are offloaded seamlessly to the cloud. And for the SD-WAN capabilities, connecting through the single central gateway is no longer cost-effective, and we increase our bandwidth and built-in redundancy at a lower cost. I'm sorry. And here is just a model design of our rack layout we used using the design software Lucidchart. And as you can see, we just went with the standard design model. Basically, our heaviest components at the bottom and our lightest components at the top. So our network connect storage is at the bottom, power supplies. In between, you see the VX rail. And also in between the VX rail, there's a keyboard video monitor set up that to be able to access our servers and be able to manipulate data and whatnot, whatever we need to do.
So with the information Ekenna was able to provide, we determined that our data center would have a max load of 80,000 servers, and those servers would be able to fit into 3,500 racks. So each rack would consume 7 kilowatts of power or pull 7 kilowatts of power per rack, which would equate to 24.5 megawatts of IT cooling. And that correlates to 6,966 tons. And that would be operating at 100% capacity, 24/7, 365 days of the year. So with that, we looked into the air management and cooling system. So the first thing for air management was to decide whether or not we wanted raised flooring or concrete slab. So we had originally chose raised flooring as there are many things we could easily stuff underneath the raised flooring. But after doing further research and speaking with mentors, we figured that would not be the greatest idea as material and installation costs is a bit higher since we would pretty much be building a platform just to put the same equipment on top of the platform. And there are other ways to route the air better than sending it underneath the floor. So in short, raised flooring is an older method and slab can hold more weight than a raised floor. So as data centers advance, we see that they become more dense with heavier equipment. So it would be easier or more so responsible to place our data center within a concrete slab. So the next became looking at our cooling system. So there are many different ways to cool a data center, and some of the ways that stood out to us were wireless traps, chill water system, evaporative cooling, and free cooling using hot tubs. So once we pitched the free cooling using hot tub, we were pretty much redirected. It was an innovative way to cool the data center, but at the same time, we pretty much had to realize that we are not necessarily some of the top data centers within the industry, and that we had to rely on some of the resources provided through our traditional research to pretty much further our studying. So with that, we chose a high aisle containment system. There are many different types of aisle frames for high aisle containment systems, like the two shown below. So on the left, this one has a neat cabling system for our cables. And then on the right, this one has a neat curtain that would be used to pretty much contain the heat. Both of these are neat, but we ended up deciding to use the Switch's hot aisle containment chimney pod. This design captivated our attention, and we love the fact that you can customize the width of the entire containment aisle as well as the chimney pod. So with that being said, this is our hot aisle containment specs. So our rack specs are 23.6 by 41.4 by 81 inches. And the longest containment aisle you can have in a data center is 50 feet with 2 egresses. So with that, we were able to account for 50 racks per containment, which would all in all come out to be 70 containment aisles within our data center. So to chill the air that comes through the plenum or the chimney pod, we would need 16 air handlers. And that number came from a couple of different formulas and calculations that utilize the air changes per hour, as well as the cubic feet per minute. So here's a coolant simulation we did using Morphe and SimScale. Morphe is a 3D modeling program, and SimScale is a CFD simulation program. So this was pretty neat to pretty much design or recreate the chimney pod system that we decided to use. And SimScale was able to further prove that our containment system would work and pull the hot air up and through the plenum and out to come back in and cool the center. So with that, our cooling system would pretty much be safe to say we will not be starting any fires. So for the cooling of the non-critical areas, we accounted for 18,000 square feet, and we added an additional 380 BTU per person. So that equated to 432,000 BTU, which is 36 tons. And with that, we would select one large split system of 40 tons, and that would take care of all of our individuals within the data center.
And so I had the pleasure of doing a power component. So in doing the power components, I actually, per Jeff, I took advice from Jeff and I created a spreadsheet. So in this spreadsheet, it contains different things, such as things that might be included in our server room or our electrical room. So as you can see, I indicated with an E or an S next to the components on the left side, which will tell you if it's in the server room or the electrical room. In the middle are some of the equipment that we decided to choose. So as you can see, we went with a Schneider-based brand. Schneider specifically specifies in data centers, and they have a lot of things that come in packages as well. I also included some things that iKenna gave me from, such as the servers. So the next column would include some of the quantities that we went with and some of the power as well. So in doing so, we went all, as you can see the bottom, the number all the way to the bottom right would be the size of our data center, which we said was about 32 megawatts. So in this case, it would be a little over 32. We had it at 33.2 megawatts. And so with PUE is actually the power usage effectiveness. So how you calculate that is by dividing the facility power by the IT power. Ideally, a PUE is about, you want to get it as close to 1 as possible. So PUE actually describes how much energy is used by computing the equipment. So in this case, the IT load from our equipment was about 23, was around 23, and then you take the 23, and then you divide the 33 by the 23, and it'll give you 1.41, which is pretty close to 1, which is as long as you want it to be closer to 1, the better. So I believe in about 2008, I believe the PUE was actually a little bit over 2. And so in doing some of this, I also had the pleasure of doing a power schematic. So I just want to stay right here a little bit and just kind of explain some things. So you see the purple from the top is the utility feed. Next under that is the blue, which is the transformer. Under that is a busway, then a generator, the ATS, the load, the switchgear, and the UPS. So the ATS serves as your automatic transfer switch. So it pretty much ensures continuous delivery to electrical power from 1 or 2 sources. So in this case, it would be delivering from the utility to the generator. And so then you have the UPS, which is the uninterrupted power source or power supply. So it's pretty much the emergency power supply for a data center. So if something happens to, let's say, the generator, for some reason, something fails, like generator or the utility, the UPS should be able to kick in and still be able to power things for a certain amount of time. So you also have the loads. So the loads pretty much consumes active electrical power. So there are also 3 different types of loads to take into account, which are the non-critical load, mechanical load, and the critical load. So just an example to describe the difference between each of these loads. Let's take into account if you're, I guess, watching a movie or something. So if you're watching a movie, obviously the lights wouldn't really matter, which would be a non-critical load in this case. So the next thing to describe the mechanical load would be your AC. The AC it's kind of important for when you're watching a movie. Eventually you're kind of going to get upset, you know, maybe over a certain amount of time. And then obviously your critical load would be something such as your TV or whatever source that you're watching your video off of. So then you also have the switch gear as well, which is pretty much composes of different disconnect switches, fuses, and circuit breakers, which are pretty much used to protect, control, and isolate the equipment. So which means it can pretty much de-energize your equipment or allow it to work. And then you have the busway, which is your distribution systems. So within our schematic, as you can see before, kind of explained this already, you have an ATS connected to our generator on both sides. So instead of doing one whole big power schematic for a 32 megawatt center, I took advice from one of our mentors named Jack. I'm not sure if he's up here right now or anything. So instead of doing a full big 32 megawatt data center, which might have been a little kind of advanced for me at this stage, we decided to just kind of bring it down a little bit to about 1 megawatt. So with that, we have the ATS connected to the generator and the utility for just in case purposes, just in case, you know, the utility might not be able to power sometimes. And so it goes on to the generator. And so right here is where I kind of included the UPSs, which I've already explained are the uninterrupted power source, which will still be able to power the data center. So also you see a line connecting in the middle to from one side to the other. So pretty much, since we are a tier 3 data center, we do have to be concurrently maintainable, which also means that we have to continuously run. There's pretty much never a shutdown. So my thinking with putting that line right there is to be able to power one side to another for just in case purposes, just in case something shuts down, another side will be able to power the other side. And so right here is where I connected a transformer to the UPS to kind of mimic like I guess you can say a PDU in a way. So then eventually with the transformers and everything, you break it down and it eventually connects to another bus. And actually in the previous slide, you don't have to go back or anything. In the previous slide, I actually had the UPSs connected to a switchgear as well. And with everything else, it'll connect eventually to a load at the bottom. And so now I pass it off to Marquise.
Thank you, Kiache. So looking into our capital expense considerations, we looked specifically into electrical and networking equipment, purchasing of land, and installation fees. So it was very difficult to find exact pricing on the equipment, and to combine that with the fact that our data center is 32 megawatts. So that is a massive data center, and getting the exact prices were difficult to obtain, but we accounted for several things specifically, such as Tor switches, catalyst switches, servers, firewalls, PDU, UPS, land costs and building the facility, workstations, installations. We looked into the main components we looked into for the OpEx was staff, taxes, maintenance, and electricity costs. So overall, from my experience looking into our budget schemes, it was a real eye-opener off the fact that data centers are really expensive. Like, it's easy to say that, you know, it's millions of dollars being put into data centers, but especially for R1, since it's being 32 megawatts, it was extremely expensive. And through meetings with mentors and research, we were able to come up with our approximate value for our data center of $750 million for Mozi's data center. So I want to repeat that, $750 million, very expensive. It compared to industry averages, there's data centers running from $50 million to $1 billion. Apple's data center has one, Google's data centers, Microsoft. So a lot of the big time companies have data centers that are very expensive. And being that we want Mozi to be an app that is a high level app that we have a lot of people using, it's going to be very expensive to build. So after looking into the expenses, excuse me, we had to go into looking for going green initiatives. So this was the steps to take to go green. We had to create a baseline energy audit, select green friendly materials for the environment, prioritize reduction of power usage, data center cooling, and a modular type data center. So things we wanted to have a point of emphasis on was mechanical lighting, electrical systems being designed for maximum energy efficiency. You want the more efficient your equipment is working, the better, and it could be also cheaper as well. So we didn't want to contain any obsolete systems, take advantage of newer and more efficient technologies. So specifically what we looked into for going green was first a solar power station. Originally, I was contemplating with my team on creating our own solar power station farm, but after speaking with mentors, they explained to me how it wouldn't be logical to do that because it was way too expensive. So we were looking at partners to do that. Con Edison and Embry Energy were two options. I know Switch's company was partnered with Con Edison, and Switch is a very good company regarding saving energy for data centers. So that was a possible option we can look into. Another alternative option would be to just use renewable energy credits. We'd have to purchase them, but these credits generated from sources of solar and wind power. So we're not just stuck with using solar power stations. We could use that alternative option as well. Now, looking into refurbished equipment, office equipment was something that we looked directly into. Telephones, printers, and desks, we could use that just to save some money. But IT Renew was a specific source where it would allow us to get equipment, recycled equipment for cheaper costs. But after speaking with mentors about that, it's kind of skeptical on, we're kind of skeptical on using it due to the fact that we want our equipment to be newer modeled and more efficient. So furthermore, I have looked into alternative construction materials in building our data center. Speaking to one mentor, she had told me that there is a company looking into creating a data center entirely from timber. That was an option I was thinking of looking for our data center, but being that timber is more accessible to fire, we decided we're gonna stay with concrete cement. Carbon air was another thing to use to lower the air emissions, and reusable water. There's treatment systems, waterless HVAC systems. Vertiv was a specific company we could use to partner with on doing that. And there's an effluent water recycling system.
So in conclusion, Mozi is a 32 megawatt data center located in Reno, Nevada. We have well thought out designs as far as our server rack design, cooling system, power schematic. We have supported renderings of our amazing building. And then we also have many initiatives to go green to save a little bit of money on our overall budget. So our takeaways is that the world would be shut down without data centers, and many major companies rely on their own data center. Also, data centers are very, 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 very expensive, but they're needed. We would like to thank you, iMasons, as well as all of our mentors, Jeff, Regina, Chang, Philip, Jack, Bill, Aaron, Natalie, Chris, Jaya, Scott, Jordan, Brendan. We would also like to thank our professors, Dr. Geddes, Dr. Lee, and Ms. Turner. As previously mentioned, we pretty much all didn't know too much about data centers. So with the help of you guys, as well as the help of many others that you guys know, this would not have been able to come to fruition. So we thank you, thank you, thank you. And again, we thank you and welcome any questions and comments.
Good job, Team 2 and Jai. Thanks so much for that. Great job. So I want to turn it over to the evaluators that are on the line to ask any questions or provide any feedback. Evaluators, come on board.
I thought you, great job everyone on the presentation. And the first question that comes to mind is obviously the quick ramp up on the data centers and getting educated, but what was the biggest challenge that you faced during this project and how did you overcome that?
Oh, I can start it off. I think the biggest challenge was really kind of figuring out where to start per se. So it was very tough on us not knowing really too much about anything. So it's like, where do we start? What kind of questions do we ask? It was like we didn't really know anything, so it was kind of hard for us to even try to figure out what kind of questions to ask. Mm-hmm. So I think now, given that, you know, talking to some mentors, they're like, you know, it took us years, decades to kind of figure out everything about a data center. So I think just the fact that we even got this opportunity and kind of learned a lot more within 8 months is definitely helpful. And I definitely appreciate the time that we had with everybody and the mentors and you guys for showing up, of course.
I would say for me, I have an innovative mind that can pretty much go from here, there, everywhere. So when it came to like coming up with various solutions, I would come up with random solutions. But again, our mentors would say like, hey, you guys need to kind of scale it down because you guys do not have the means to do that. So I guess for me, it was kind of just like sticking within, not even the project, but sticking within the means of what we could actually do.
And so to follow up on what those two said, for me personally, I felt like the attention to detail was so important because there's so much components going into building a data center. It's so easy to not pay attention to every specific detail you need. But at the same time, you can't be too concerned on one specific detail because there's so much factors going into it. So it's just trying to balance everything and account for everything, which was a very hard task to do, but it was a fun experience that I enjoyed.
Yeah, for me, I guess it was just jumping down the rabbit hole of learning, you know. So you ask one question or you Google something, and then you get a whole, it's like opening a door to like a million other doors. And then you keep going down, learning more and more and more. And just having to like aggregate all that information into like a concise presentation and knowing how to make it make sense was like the hardest part for me.
It was a great presentation, so really enjoyed it, and you could see that you guys put a lot of thought and energy into every aspect of the data center design.
And this is Dean. I want to just put one comment out there. Jay, is it Jay or Jai?
Jai.
Jai. So you said you had to be throttled back. Mm-hmm. I would encourage you not to be throttled back.
Yes.
Okay. Because look, think big.
Mm-hmm.
If you look at what's going on across this group of people in here, I mean, I looking at faces, their portfolios are freaking huge, you know, and they have to think bigger and bigger and bigger and bigger about scale. So don't ever be worried about that. It's easy to throttle back, but if you don't think big enough, you'll never get the big out of it anyways. So
you can always let the CFO throttle you back. The rest of the time, you can just build as big as you want. So this is Eddie. I just wanted to commend you all. First, the first thing I wanted to commend you on was the approach. Oftentimes, the approach is approached as building a building or building, you know, an engineered space and then putting a shell around it. What I like about what it appeared to me and the way you communicated was that you started with the application's requirements from an IT kit requirement. You looked at how to scale that up, and then doing so, you identified whether or not you needed one or two buildings, and you were able to really arrive at the design practice, which is in fact the most appropriate and important way to apply these solutions, is to look at what the products are that you're creating this environmental controlled space for and this critical facility for. Second thing I noted, and I just wanted to encourage you in the future, if you have this opportunity to do this again, is that sustainability can be part of your site selection criteria as well. So choosing a location that offers highest sustainability rewards is a great one. It just so happens Nevada, which is where you chose, is like in the top 3 sustainable locations in the United States to operate a facility like this. So congratulations on that choice. And then the last thing, and I appreciate the nods and your considerations of Switch for so many things, me personally. But on another piece of this, I just wanted to raise this up, and that was the attention to detail that you had for the interrelationships of electrical to the facility space, the amount of tools that you use to gather your data and make those assumptions, even freely available tools such as, you know, where risk factors were for natural disasters and things like that, is a great is a great testament to the abilities and the skills of the team. And I found this to be a great presentation for Capstone, and congratulate you on such a good work.
I'd like to just build on a comment that Eddie made around the approach. So I think it's, you know, easy to come at this and think about a data center as a box or a building for something. But, you know, our friends at Google coined in a white paper many years ago the warehouse-sized computer, and the fact that you've approached this and thought about this in a holistic manner. So, you know, I was really pleased to see that, you know, you covered a lot of ground, and I think it sounds like you realized, you know, where do you begin? Do you begin with what is inside the box, outside the box? Where's the box going to go? How are you going to connect the box, power the box, cool the box, make it look good? There's so much to think about. So yeah, I think, you know, really good to see that. I do have one question for you, which is, you know, as you went down the rabbit hole, did you find, I guess, what was your, did you find resources out there? I mean, you can Google anything now, right? So was there a resource that stood out for you more than others? Or did you just have to literally find your way around the internet and all the things out there to help you kind of educate yourself and put this together?
Along with the mentors, that was probably the biggest resource, reaching out to mentors. But doing our own research, we were able to find information, but I feel like it was more general level information from sites. So once reaching out to mentors and being able to speak with them as well, we were able to dive more deeper into each specific area we were asking about.
For me, it was actually the hyperconverged infrastructure was actually very new for me, and it's also like a new kind of technology. So like that on its own has so many unexplored paths to go down. I actually looked at kind of building my own hyperconverged infrastructure for the data center, and then with that, you have to figure out every single minute component that goes into the hyperconverged infrastructure to be able to have your own hyperconverged infrastructure. And that was just like, okay, this is so much detail and so much information that I don't know how I'm going to be able to like make this make sense for the project. So we just went with like a vendor in Dell, and like it was just so happened that they happen to have their own technology, that their suite that they're running. So that was pretty convenient.
One of the things that stood out to me in your project, picking up on a couple of the comments that were made, it was wonderful to see you took and I'll reuse the word, so I'll just use a more holistic approach even on your green thinking as well. That's going to be, for this industry, this is going to become, you know, key and critical for us. And it's a lot more than just green power, which you guys clearly touched on as well. It gets into the building materials, which you touched on, the panels you put around the building, brilliant, by the way, right call, right way to think of it. Biodiversity, it's going to play into the use or non-use of water going forward, just as important in the sustainability, depending on where it's at. And I thought y'all did a really good job of not making it an afterthought, but when you look at the building's design and some of those things, it was in the forefront of it. And I actually think it's wonderful to see that. It's actually going to become much more critical in our industry going forward. And some of us that have our 20, 30 years of experience need to make sure we're putting it front and center. And for the record, Dean, Jai is joining us at Edge Connects here upon graduation, and I am not going to pull the reins in at all. And welcome, Jai. Thank you for sending in your acceptance letter. Welcome aboard.
That's so cool. Congratulations. I want to double down on that, Randy. And by the way, good grab. I think I can't wait to see whoever gets picked up faster here. On the sustainability side, the one thing in the presentation that I just want to encourage you to look at, I think Marquise, you were talking about the comparison of an IT Renew equipment, right, and the new shiny equipment, the newer stuff of it. If you look at what Randy just walked through, sustainability is really end to end. Every aspect, from sourcing what you're getting to how you're going to dispose of it. And one of the things that has emerged lately is that a waste stream is becoming a supply chain. Let me explain that. if you think about IT Renew, all the equipment that's coming out of these large players, and some of them are represented on this call, right, is considered old and out. But it's like 3 to 4 years old. And so when you now put it back into this, it gets renewed and it comes back into a data center. They have a 3-year warranty on it. The price for the same performance is less than half. The carbon, so think about that. I can get the same performance at half the cost. Eddie talked about the CFO. Imagine now you can say, I can go back and get compute that's going to get the same performance, but half the cost. And then you say, and 70% of the embedded carbon, all the manufacturing process, the precious minerals, all the other elements of the shipping is all gone. So that waste stream becomes a supply chain at volume already. So it's a really interesting new world right now. And we have a whole paper written on this in iMasons about the circular economy. Take a look at that one, because it's a totally different way of thinking about how you supply capacity inside of the data center.
The fact that you guys have been doing all this whilst probably working from home most of the period, we're all suffering with, well, firstly, we're all making great use of data centers to make that as effective as possible, but we're human at the end of the day, and that it's still not easy. We're still learning that in our industry, and for you guys to have gone from, if I understand it right, a relatively zero knowledge of data centers to the outturn that you've shared with us today is fantastic. And what also jumped out at me is the fact that you came across as a team, that you all played your part, you were all involved. I can only imagine some of the fun that was, or some of the inquisitive minds and some of the conversations that went on your own gatherings, your own workshops. But one thing that jumped out at me as well is the way you understood the building, how different areas operated with each other, how you might get services from one space to another. Echo the comments about sustainability. Think about climate and the impact that can have on some of the systems and services that you select. But great shout on the cost of these facilities, and the fact that you realized when you came up with such big numbers that actually there's a commercial constraint. Well, there's a commercial consideration, I should say, and that you understood that. Well, it's not just 750 million. We need to challenge that and challenge ourselves. And what can we do smarter to make that work? Just finish on one question very quickly. If you could turn the clock back to the start of this process, what advice would you give yourselves, and what advice or what feedback would you give to iMasons as to how we could support you better in this type of exercise?
I thought great research, great job on the industry benchmarks included throughout. There were obviously a lot of decisions made to arrive at the proposed solution. What was the most challenging decision you made as a team throughout the project to arrive at a proposed solution at each stage in the process, from site selection through project completion?
Yeah, site selection, being that we didn't have any bias on which specific site to select, since we had no background with where data centers operated. So we just had random sites from several regions, and just narrowing it down, eliminating bias in order to choose which location we would end up using. That was a process. Took some time, but fun process.
I would say the architects have been a little quiet right now, but I would just like to show my appreciation, or our appreciation, for them being patient with us. So throughout the process, we had to choose different servers and cooling equipment and stuff like that. But each week it was almost like we would bring a new piece of equipment to the table. And Chang was pretty much saying hey, you guys should pretty much kind of speed up the process, because they can't move forward if you guys don't pick. So I would say thanks you guys for being patient with us, being indecisive on our end in regards to picking equipment. But that was kind of one of the little toss-ups that did come into play throughout I guess, kind of this year, but last year as well.
Bit of real world in that, by the way.
Does that sound familiar?
No kidding.
I think you guys did an incredible job telling the story with visuals as well, not just reading through the slides. So great job, and another real world example, talking about the story rather than just talking to the slides. So well done.
thank you so much to the students. Great job in this presentation. And thank you to the evaluators for, investing your time in this. It is pretty incredible. 8 months ago, these students barely knew what a data center was, and you see where they've ended up. And as Ian kind of commented, this all in a time of COVID when they've been in their bedrooms for a year, rather than actually collaborating in person in a lab somewhere. So it's pretty remarkable. So I wanted to talk about where do we go from here. So turns out Hampton University is part of a consortium of the electrical and computer engineering departments at 18 minority serving institutions, mostly HBCUs and Hispanic serving institutions, called the Inclusive Engineering Consortium, making up a super department of 180 faculty and 2,000 students. And we've been in conversation with the IEC since starting this project. And tomorrow, it turns out, we're meeting with the reps of many of the schools to talk about, this project, how it went, and to pitch them to host an iMasons Capstone project at their schools next year. So each of the four of us, Philip, Bill, Chang, and myself, have all agreed to be lead mentors at different schools next year. So we're going from our team of 4 mentors to supporting 4 different schools next year. And so we're pitching this to IC tomorrow. And I think we'll get our 4 schools. But the ask here is that each of us, as we go to new schools, we're each going to need another little mentor team of 3 or 4 people, to be the team at that school. And so that's the first ask of people on this call, is if you can support us in being a mentor to meet with a group of students weekly, we would really love to hear from you. It's been a great experience, and Bill and Philip and Chang have all spoken to that. This year we supported about a dozen students, and next year we should be turning 30 or 40 students or so towards our industry. So it's a really great opportunity to expand. So that's the first ask. The second ask is, as somebody mentioned, every time the students have a question that is kind of beyond our pay grade, we have the pleasure of being able to say, God, I don't know exactly how much UPS's cost, as an example, but I know somebody who does. And so we can refer them out to people in the industry that know everything that we need to know, that they need to know. So we have this list of experts on call that have been able to, we can connect the students to when they have questions. If any of you, are willing to donate just an hour of your time to answer student questions on something you're expert at, I'd encourage you to let us know, and we'll put you on the list, and you may get a call if you're lucky. So that's the second ask. The third way you can all contribute and support this is iMasons provided all these students a scholarship to help with tuition while they were learning about our industry. And the funds that make that possible come from all of you, the iMasons members around the world. So we recently stood up a 501c3 charity. It's all stood up and working, and it's now connected to the employee giving programs and the employer matches at Apple, AWS, Facebook, Google, Microsoft, and many other large corporations. So if any of you work for those companies and you want to give through the employee giving program, because the employer matches it. And if any of you want to give personally, it's now tax deductible because it's a 501c3. Just go to imasons.org/donate, and there's a link there to donate. And 2 years ago, we set a goal to raise $1 million for scholarships. And we're now over halfway there with the help of all of you. So thank you very much for your contributions. You saw today where that money's going. So we welcome your participation in that aspect. And I wanted to come back around to one thing we mentioned a little while ago. When we started this conversation with Hampton, the idea was to develop a data center lab. And we've been continuing that conversation. We're now trying to get organized to develop a curriculum that could be delivered at schools in a lab. And whether those labs are actually in the school or at a colo site or the corner of a hyperscale facility, nearby, how would we develop a replicable curriculum that we can install, at dozens of universities around the world? So we're kind of beginning to kick off that project. if anybody would like to participate in a hands-on actual lab project and developing that curriculum, would appreciate your help. And the last ask is, Jai has accepted a position in the industry. Some of these students are still looking for just the right opportunity. If you see anybody here that would round out your team at your company, we've put a link to all of their LinkedIn profiles on a web page that, if I remember to, I'll put it in the chat. But it's on the iMasons website. Reach out to them. Some of them are still looking for an opportunity. So I wanted to just close this by thanking the iMasons sponsor partner companies that make this thing possible. It's because of your support that iMasons is able to do these things for our community. So thank you to the foundation partners and to the Keystone and Capital partners within iMasons. Thank you all for participating.